Today's lesson is the starting of chapter 4, and we're in lesson 1 for chapter 4, lesson 4.1. It's about zero and negative exponents. I should say this is another easy topic, for this is only a review of your grade 7 topic on the law of exponents. So let's start. Today's memory verse is found in 2 Corinthians 5, verse 17. In the English Standard Version, it says, "Therefore, if anyone is in Christ, and he is a new creation. The old has passed away. Behold, the new has come." Today, our keywords are simplify, new expression, negativity. We can sell negativity. And RMVC boosters is very much related to that. We'll be canceling negativity. How can you cancel negative thoughts and actions in your life? You need to list 3 strategies. May I encourage, I noticed that some of our modular students are not answering the MVCA boosters. Please take a short time to answer that. I don't need long explanations. I only need short ones because this will give you extra points, for the topic. Now, at the end of today's lesson, we will be able to apply the laws involving positive integral exponents to zero and negative integral exponents. I told you a while ago that this is just a review of our grade 7 topics, and it's on the law of exponents. Now, for our venture activity, you will calculate the distance between the sun and the earth. If you have an answer to this, post it in our Telegram group chat. And the first one who can give the answer, correct answer, will get the bonus point. The speed of light is approximately 3 times 10 to the power of 8 meters per second. If it takes 5 times 10 to the power of 2 seconds for light to travel well from the sun to the earth, what is the distance between the sun and the earth? You need to post your answer together with your procedure. Again, your answer and your procedure in our Telegram group chat. And the first one to get the correct answer will get 5 bonus points. Answers can be in scientific notation or in standard notation. Now, we have 5 basic laws of exponents. We have the product law, quotient law, power of a power law on a product, and the 5th one is the power law on quotient. Let's start. Ready? The first one is the product law. Let me just explain it. The product law tells us that if 2 real numbers are multiplied of the same base, then you will just add the exponent. For example, if we have y to the 4th multiplied, this is not a point, okay? It's a raised dot. It means multiplication. Y to the 4th times y to the 5th power. If you multiply the same base, you copy the base and we add the exponents. 4 plus 5. So the answer is y to the 9th power. Another, 2 squared times 2 cubed. Same base, so we copy the base, then we add the exponents. 2 plus 3, that's 2 to the 5th. But since we have a numerical expression, we need to simplify it more. That is 2 times 2, 5 times by itself, times 2 times 2 times 2. Again, the exponent tells us how many times we are going to multiply the base by itself. It's not 2 times 5, okay? The answer is not 10. You multiply. 2 times 2 is 4, times 2, it's 8.
32.
Times 2, 16. Times 2 AP. The answer is
32.
32.
that one. Next, quotient law. The quotient law tells us that if we divide numbers of the same base, we simply subtract the exponents. Example, wait for a while. Example, y to the 5th divided by y squared. We will just copy the base, then subtract the exponents. 5 minus 2, that is y cubed. Or if we have y squared over y to the 5th, ma'am, where will I subtract it? You subtract it to the one with a greater exponent. So we transfer at the bottom. We have y to the 5th minus 2. What happens to the numerator? Can you tell me? What happens to the numerator? What will I place? I need to write what number? I need to write 1. So it becomes 1 over y cubed. Again, the quotient law tells us that if we divide numbers of the same base, we simply subtract their exponents. Next, power of a power. If a real number with m as the exponent is raised to another exponent, then we multiply the exponents. Example, x to the power of m raised to the power of n. We multiply the exponents, so that becomes x to the power of mn. Example, y to the power of 2 raised to the power of 5. We simply multiply the exponents. That is y to the power of 10. Another, x cubed y squared to the power of 5. Then we will distribute the exponent. That becomes 3 times 5 is 15, x to the power of 15. 2 times 5 is 10. So y to the power of 10. This is now our answer. The next one, power law on a product. Oops, this is the one I mentioned a while ago, but let me add more. For example, 2x cubed y to the 7th raised to the power of 2. Okay, prepare in your chat boxes. Can you tell me what is the answer in the chat box? What is the answer for quantity 2x cubed y to the 7th raised to the power of 2? The first one, where's my magic ball pen? The first one who get the correct answer will get a bonus point. Lesson 4.1. Ready? Waiting for your answers. Okay, very good. Congratulations, Lalaine. You got the correct answer. Here, we have 2 squared x. 3 times 2 is 6. Y, 7 times 2 is 14. Do not forget the 2. But we need to simplify this. So it becomes 2 squared is 4. X to the power of 6. Y to the power of 14. Congratulations, Lalaine, for giving the correct answer. Now, I'll give another one. Ready? Negative 3, A, 4 to the power of 4, B to the power of 2, raised to the second power. Ready? Go. In the chat box, send me the correct answers. Now, how will you do it? Distribute, right? Negative 3, do not forget negative 3 in the parentheses, to the power of 2. A, 4 times 2 is 8. For B, 2 times 2 is 4. Now, we need to simplify our numerical coefficient. And remember, when a negative number is raised to an even exponent, the answer is positive. But if a negative number is raised to an odd exponent, the answer is negative. Why? Example, times the power of 2. Diba pair? Same signs? Positive. But if we'll have 3, it's odd. These 2 pair it, it's positive. There's no pair, so the answer becomes negative. So this one, negative 3 squared is 9. 8 to the power of 8, B to the power of 4. Very good. Now let's go to the next one. The next is the power law on a quotient. It tells us that if there is a power that's raised outside, then we need to distribute it to the ones inside. Example, x to the power of 3 over y to the power of 4, all raised to the power of 5. So simply multiply x to the power of 15 over, at the bottom, y to the power of 20, because we have 4 times 5. The next one, the zero exponent. When a number or a variable is raised to the power of 0, the answer is 1. As long as x is not 0. Example, 5 to the power of 0, 1. 7 to the power of 0, 1. Negative 3 to the power of 0, 1. X to the power of 0, 1. X squared, y cubed, z to the 10th power to the power of 0, 1. That's it. Let's have more practice. Ready? Okay. In the chat box, this time no bonus points, okay? For practice, what's the answer for A? A to the 5th divided by A to the 5th. In the chat box for practice, can you write it? Oh, very good. That's 1. Why? A to the 5th minus 5 is A to the power of 0. So the answer is 1. Next, number 2, letter B. 8x to the power of 0. No. This is different when you write it this way. This is 1. But here, not all are raised by the power of 0. It's only this one. Very good, Ali. The answer is 8. Here, 8. This one is equivalent to 1, right? So 8 times 1. The answer is 8. But if I write it this way, all to the power of 0, the answer is 1. The next one, letter C. Ready? In the chat box. Very good, 1. Actually, it's the same as 5 divided by 5. When the numerator and the denominator are the same, the answer is 1. Like this one, A, 1. Here, 1. Next, letter D. What's the answer? Very good, 1. When all numbers are raised to the power of 0, the answer is 1. Now let's continue. What if there are negative exponents? Here's my technique. If the negative exponent is in the denominator, transfer it up and it becomes positive. If it's on top, you transfer it down and it becomes negative. Now, common error. Common error is sometimes you treat the number and the variable the same. Example. Well, let's first have a drill, okay? 5 over x to the power of -3. The negative exponent is at the denominator. So you transfer it up. It becomes 5x cubed. Let me have another one, okay? 5x squared over y -3 z to the power of 2. Now, you only look for the one with the negative exponent, and that's the one that will transfer. So for here, it's this one. It's in the denominator, so you transfer it up. Ma'am, what will happen to the rest that are already there? Copy. So numerator, 5x squared. Copy, right? This one is negative in the denominator, so transfer it up. Once you transfer it, the now, the denominator, it's z squared. Why do we only copy? Because the exponent is positive, so no need to change it. Another one. Ready? 5x to the power of -2 over y to the power of -3 and z to the power of -2. Now in the chat box, for a bonus point again, can you simplify it? Ready? In the chat box, let me first pause the recording. There's no negative exponent for 5, so it must stay. Now for x, the exponent is negative. It must go down. X squared. Next, in the denominator, the exponent of y is negative, so it must go up. Y cubed. Next, the exponent of z is negative, so it must transfer. It must go up. Z to the power of 2. So this is now our final answer. 5y cubed z squared over z to the power of 2. Ma'am, when will the number transfer? Let me give you an example. 5 to the power of -2 over x. That one. The number has a negative exponent or numerical coefficient. So it must be transferred. It will go down. 5 squared. X has no negative exponent. It will stay. Oops. Nothing left on top, so we write 1. We need to simplify our numerical coefficients, 5 squared. So that's 25x. Our answer is 1 over 25x. Let's have more examples. Ready? Okay, in the chat box, can you tell me what's the answer? Simplify. 3s to the negative power of negative 2. 3s to the power of negative 2. Ready in the chat box? AP, there should be no negative exponents in the final answer. Friends, here it's negative, right? So what do? We need to transfer. No, AP. Why did you transfer 2 only? Oh, there, Ali. Very good. Now, here, 3 does not have a negative exponent. So it stays on top. S has a negative exponent. So it must transfer down. Just copy S and the negative exponent will become positive. S squared. This is now the answer. Next one. Ready? There, in the chat box, 7 over y to the power of negative 8. 7 over y to the power of negative 8. Very good, Jared. 7 does not have a negative exponent. It stays on top. This one has a negative exponent. So we transfer it to the numerator. That's y to the power of 8. This one. Very good. Next, this. In the chat box, ready? 2 over 9c to the negative 5 power. What's the answer? No, AP. Nice try, but it's not the correct answer. Oh, very good, Lalaine and Jared and Ali. Very good. Here, 2 does not have a negative exponent. It stays, right? 9 does not have a negative exponent. Again, dili lagi niyo sila package, oh. Di na sila package, ha? Lahi ang 9, lahi ang c to the negative 5. So 9 does not have a negative exponent. It stays. The variable c has a negative exponent. Transfer up. So c to the 5th power. Very good. Then here, ready? Go. In the chat box. Here. Let's start first with a variable, okay? X to the power. Yes, almost there, Lalaine. Almost there. The only problem is you did not simplify this one. Okay, almost there, Jared. But the variable is wrong. Okay, x to the negative 3. Negative exponent, transfer down. So x cubed, right? Next, y to the negative 4 has a negative exponent. It goes up. So y to the power of 4. Actually, Lalaine's answer is very close. The only difference is this one, negative 4 over 20. It looks like this. Oh, very good. Almost there, Lalaine. But the sign is different. Here. Negative 4 and 20. You need to divide it by its greatest common factor, the GCF. That's the GCF of 4 and 20. It's 4, right? So 4 divided by 4. 1. So negative 1. Denominator, 20 divided by 4. 5. So the answer is negative. You could place a negative here. 1, it's okay not to write 1 on top. Then 5 at the bottom. So the answer is negative y to the power of 4 over 5x to the power of 3. Like what Ali is typing. That's it. So that ends today's discussion. Let's have a very